from our question given, we're to consider a plate, we're to consider what? Viscosity of a plate. Now, considering viscosity of a plate, we'll simply be given two plates and we're asked to get the dynamic viscosity and also the kinematic viscosity of those plates. Now, looking at our first question here, we were given that a plate is 0.05 millimeter distance from a fixed plate, and that fixed plate moves at what? 1.2 meter per second and requires a force of 2.2 Newton per meter square. To determine this speed, find the viscosity of the fluid between the two plates in poise. If the fluid is assumed to be water, what is the kinematic viscosity? And the kinematic viscosity should be in what? Strokes. The first thing you do when you have a question like this is to identify your given parameters, because you use your given parameters to find your what? Your unknown. And what are your unknown? Your unknown is what? The first unknown is what? Your dynamic what? Viscosity. And they said your dynamic viscosity, after getting your answer, imputes that answer to be in what? Poise. That's the first thing you were given. Now the second question you were given here was to find your what? Kinematic what? Viscosity. And your kinematic viscosity should be in what? Strokes. Are we together? So what you do is bring out your given data, you use your given data to find your what? Your unknown. Are we together? Now what are your given data? Now from what we have here, we were given that the distance from your fixed plate to your moving plate was what? 0.05 millimeter. Now let's bring out the graphical representation of this. So we have two plates. We have the first plate, which is always fixed, the fixed plate, and this first plate is fixed, right? So since we have this plate to be fixed, you have your velocity of your fixed plate will be what? 0. Now we have another plate which is always our moving plate. Now what is the question saying? The question simply says from your fixed plate to your moving plate you have a distance, and what's that distance? 0.05 millimeter. So what you do is you convert 0.05 millimeter to what? Meter. Are we together? Now we were given the velocity for your moving plate, and they said the velocity for your moving plate was given to be what? 1.2 millimeter per second. This was what we have here. So we were given the moving plate to be what? 1.2 meter per second, and that was the velocity that was given to us. Now from what we have here, we can see that the distance is what? 0.05 millimeter, and you want to convert this to meter. What do? You multiply with 10 raised to the power of what? -3. So this is 0.05 times 10 raised to the power of what? -3. And this will be in what? Meter. Are we together? Now for you to get your du here will simply be what? Du will be equal to what? The moving plate, u of m, which is the moving plate, minus the fixed plate, which is what? U of what? F. And we know that the moving plate was given to be what? 1.2 meter per second, right? And you are minusing this with you are subtracting this with your value for your fixed plate, which is what? 0. And if you punch your calculator, you simply have what? 1.2 meter per what? Second. So this is the value for your what? Du. Are we together? Now look up. We were also told that a force was required, which was what? 2.2 Newton per meter square. And what is this force? Looking at the unit, this unit is having what? Newton per meter square. And what is this telling you? You were given what? Shear stress. So you are given tal to be what? Tal will be what? 2.2 Newton per meter square. What are you also given? You were asked to find your dynamic viscosity. This is your dynamic viscosity. And you're also asked to find your kinematic viscosity. Are we together? So you are asked to find your dynamic viscosity and also your what? Your kinematic viscosity. Are we together? Now, what's the first thing you are going to do? The first thing you have to do is, from what we have here, remember that our dynamic viscosity, which is what? U, is equal to what? Tal divided by du over what? Dy. Where your tal is your what? Your shear what? Your tal is your shear stress, right? While your du over dy is what we call our what? Shear strain, or your what? Velocity what? Gradient. Now, imputing those parameters, we have that our tal here is what? 2.2 meter per second, right? Divided by, what's your du? Your du was given to be what? 1.2. We had our du to be what? 1.2 from what we have here. So your du is what? 1.2. So you have 1.2 what? Meter per second. This is Newton what? This is Newton per meter square, and this is what? Meter per second. Are we together? Now we divide this with what? What's your du? Your du here simply stands for the distance of the two plates, and the distance of the two plates is what? 0.05 times 10 raised to the power of what? -3 in meter. So we have this to be what? 0.05 times 10 raised to the power of what? -3 in meter. So what you do is, don't punch everything like this in your calculator. What you simply do is, you first punch what you have here, 1.2 divided by 0.5 times 10 raised to the power of -3. After getting your answer, then you are going to punch 2.2 divided by your answer, and you arrive at your final value for your dynamic viscosity to be what? 9.167 times 10 raised to the power of what? -5 Newton seconds per what? Meter square. So this is the normal unit we know for what? Dynamic viscosity. But for our question, from the question given, your question was given for you to find your dynamic viscosity in poise. So your unit will be in what? Poise. So what do you do? Now remember, we talked about dynamic viscosity, and we said when we are considering dynamic viscosity in poise, we know that one poise is equivalent to what? 1/10 Newton seconds per what? Meter square, which is also what? 0.1 Newton seconds per meter square. Now we're asked to find this in poise, so we can call this x. We can call this x, and x is now equal to what? 9.167 times 10 raised to the power of what? -5 Newton seconds per what? Meter square. Somebody will now ask me, why are we considering this as x? We are considering this as x because we want to get this value in what? Poise. That's why we are imputing x here. Are we together? Now, imputing x here, what will you simply do? You cross multiply your equation. If you cross multiply, you will simply have 9.167 multiplying what? 1, abi? And that will give you what? 9.167 times 10 raised to the power of -5 Newton seconds per what? Meter square, multiplied by your poise here, which is poise, right? And this also will now be what? This is 1 divided by what? 10. And 1 divided by 10, you simply have what? 0.1. So this will be what? Dividing what? This will be dividing what? 0.1 Newton seconds per what? Meter square. Such that this will go out, right? And you are left with what? Poise here, and your value for what? For your denominator to be what? 0.1. Now if you punch your calculator, you will simply have that your x now will simply be equal to what? 9.167 times 10 raised to the power of what? -4 poise. So this will be the unit for our what? Dynamic viscosity. And the unit for your dynamic viscosity will finally be what? 9.167 times 10 raised to the power of what? -4 poise. Are we together? Now we've seen the reason why we had to put x here, such that we'll have the value to be in what? Poise. Now remember, we are not done. Why are we not done? We are asked to find your kinematic viscosity also in what? Strokes. Find your kinematic viscosity in strokes. But for you to find your kinematic viscosity, remember you were asking your question that the fluid is assumed to be what? Water. We are assuming that the fluid is water. So what should come to your mind is density of what? Water. Density of what? Water. Now for us to find our kinematic viscosity, we know that kinematic viscosity what? Viscosity is equal to what? Dynamic viscosity divided by what? Density. But in this case, we are taking our density here to be what? Density of what? Water. So what do? We already know dynamic viscosity, and what's the value for our dynamic viscosity? The value for our dynamic viscosity was what? 9.167, right? So we have our dynamic viscosity to be 9.167 times 10 raised to the power of what? Minus 5 divided by what is now the density of water. Remember, from our properties of fluid mechanics, where we mentioned what? Specific dynamic, specific density, specific mass, and the rest of them. When we were considering specific gravity of a particular fluid, I told you that the density of water is a constant value that will be given to you. If you are not giving the density of water as a constant value in your question, then you should take that the density of water is always what? 1000 kilogram per meter square. So we have this to be the density of water, and the density of water is what? 1000 what? Kilogram per meter square. Are we together? So what you do is you punch your calculator 9.167 times 10 raised to the power of minus 5 divided by 1000, and you simply arrive at the value 9.167 times 10 raised to the power of what? Minus 8. And what's the unit for kinematic viscosity? Meter square per what? Second. But remember, you were asked to leave your answer in what? Strokes, not meter square per second. So what do? We also know that 1 strokes is equivalent to what? 10 raised to the power of what? Minus 4 meter per second. Recall, we know that 1 strokes is equivalent to what? 10 raised to the power of what? Minus 4 meter square per what? Second. So if we were to calculate this to be in strokes, then we don't know the value of strokes, and we represent that value to be what? X. And we said X is equal to what? 9.167 times 10 raised to the power of what? Minus 8 meter square per what? Second. Such that when we cross multiply, we'll finally have an answer to be in what? Strokes. Now let's cross multiply to see that. Now if you cross multiply, you are cross multiplying, this is multiplying this, and X is multiplying what we have here, right? Now if you do that, you simply have this to be 9.167 times 10 raised to the power of what? Minus 8 meter square per what? Second. Remember, this is multiplying 1, so it still remains the same thing. But the only thing that will be added to your value here will be what? Strokes. So this will be multiplying what? Strokes. Are we together? Now, what are you left with on this other hand of your equation? On the other hand of your equation, this is what? 10 raised to the power of what? Minus 4 meter square per what? Second multiplied by what? X. So what you do is we divide both sides by 10 raised to the power of minus 4 meter square per second, and you divide here all through with what? 10 raised to the power of minus 4 meter square per what? Second. Now you can see that your meter square per second will cancel out meter square per second, and you are left with what? Strokes here. But remember, what you have here is what? 9.167 times what? 10 raised to the power of minus 8 divided by what? 10 raised to the power of what? Minus 4. Remember, on this side of your equation, this has cancelled out, and you are left with what? Just X. So you finally have your X value. Your X value will be equal to what? After doing your division, your X value will be equal to what? 9.167 times 10 raised to the power of what? Minus 4 strokes. So the value for your kinematic viscosity will simply be what? 9.167 times 10 raised to the power of what? Minus 4 strokes. So you've succeeded in calculating for your dynamic viscosity, which is in what? Poise, and your kinematic viscosity, which is in what? Strokes.